Greetings everyone. My name is Shoshab Sadhu, and on behalf of my co-authors Dr. Biswajit Patra and Dr. Tanmay Basu, I'm honored to present our work from the Indian Institute of Science Education Research, Bhopal, India, in FinNLP workshop at EMNLP 2025. Our paper is titled Structured Adversarial Synthesis, a multi-agent framework for generating persuasive financial analysis from earnings called transcripts. The core idea is the existing AI systems for financial analysis are designed to be cooperative. We argue that to achieve human-level robustness, they must be adversarial. We built a system to prove it, and today I will show you how that system works and why this approach is necessary evolution in the field. The analysts of corporate earnings call present a fundamental challenge in financial NLP. There's a big difference between summarizing what was said and synthesizing what it means. The core problem of the earning to insight shared task is the distinction between this, the what, and the so what. On the left, we see what most current systems actually do: factual summarization. They can extract key numbers like an EPS or a sales increase. This is useful, but as the slide shows, it lacks context, it misses causality, and it is not fundamentally decision oriented. It tells you only what happened. On the right, we have persuasive synthesis. This is the so what thing. It takes the same fact but weaves them into a narrative. It connects the dot. It reveals underlying insight and it constructs a testable thesis. For example, it doesn't just state the guidance was raised, it analyzes the quality of guidance, revealing that 64% of it came from acquisitions, not core operational strength. The earnings to insights share task is a brilliant task because it is explicitly designed to measure a system's ability to produce the kind of persuasive synthesis, and that is the problem we set to solve. To achieve this, we introduced Structured Adversarial Synthesis, or SAS, our framework. This system is modeled after deliberative workflow of a professional investment committee, and it operates in three distinct phases. Phase 1 is the intelligence distillation. Here, a committee of three specialist agents works in parallel. A quantitative analyst extracts objective financial metrics, a behavioral analyst decodes the management tones and subtext, and a market analyst synthesizes the historical market data to provide pre-call context. Together, they produce a single structured CIO briefing. The phase 2 is the core of our contribution, the structured adversarial debate. This is not a chaotic open-ended chat. It is a deterministic 5-act protocol. A bear and a bull agent constructs opposing theses. And these theses are then rigorously cross-examined by a devil's advocate agent to stress test their every assumption. Finally, in the phase 3, the final judgment and synthesis, a concluding committee of agents adjudicates the debate and synthesizes the entire stress-tested analysis into a single coherent and persuasive final report. To prove the value of our architecture, we designed a rigorous evaluation study centered on the three core research questions. First, for the research question 1, we wanted to measure the value of distillation. We asked, does our multi-agent intelligence gathering in phase 1 actually improve the final analysis? Second, the research question 2, we tested the value of adversarial debate. We asked, is a structured adversarial process superior to a purely cooperative one? And finally, the research question 3, we isolated the value of debate structure. We asked, does our moderated multi-turn debate protocol outperform a simple unstructured exchange of views? To answer these questions, we benchmarked 4 systems of increasing complexity: a naive single-agent baseline, a strong non-adversarial cooperative baseline, an ablated version with a simple unstructured debate, and finally, our complete 5-act structured framework, SAS. For our evaluation, we used a blind head-to-head comparison protocol with GPT-4o acting as a powerful impartial judge to determine a definitive winner in each pair. Our results are conclusive and directly answer our research questions. Looking at the top of the table for research question 1, we see that the cooperative system S2, which benefits from our intelligence distillation, decisively outperforms the single-agent baseline with a nearly 72% win rate. This confirms that our phase 1 is a critical value add. For research question 2, the results are even more striking. Our full adversarial system S4 achieves a 68.75% win rate against the strong cooperative baseline. This provides strong quantitative evidence for our central thesis that for this task, an adversarial process is a superior one. And for research question 3, we see that our structured moderated debate in S4 outperforms the simple unstructured version in S3, proving that the structure of debate protocol is a key innovation. A linguistic analysis further shown provides a potential explanation for this. Our structural adversarial synthesis full model produces reports that are simultaneously more readable with a significantly lower FKGL score and a far more lexically sophisticated with a much higher abstractiveness score. This unique linguistic profile of being both clear and nuanced aligns closely with the qualities of persuasive expert level writing. In conclusion, our work has led to 4 key takeaways. First, we have shown that agentic architecture is more important than just agent count. The design of interaction is the critical determinant of the performance. Second, our central claim is validated. Adversarial debate is decisively superior to cooperative baselines for this task, achieving a 68.75% win rate in head-to-head comparisons. Third, we identified a unique linguistic profile for our SAS reports, high readability and high lexical sophistication, which we argue is a key driver of their persuasiveness. And finally, our system's performance was validated externally, achieving a competitive 5th rank in the official Earnings to Insight shared task. Looking forward in the future, we see exciting opportunities in applying this framework to other paradigms like scientific review and LLM tutoring. Exploring more granular agent specification and specialization can be a way out. And also, there's an open playground in developing new metrics for human perceived clarity. Our paper and code are available at the following GitHub link. Thank you for your time and attention. I'd be happy to answer any questions addressed at the said email IDs.